All right, next section, concavity and the second derivative test. So we talked about the first derivative test last week, and that tells us where we have relative extrema. All right, we're going to go ahead and continue and look at some different ideas. So we can tell where a function's increasing or decreasing by analyzing the first derivative. But how is it increasing? Okay, and when we're talking about how something is changing, how is the derivative changing? We're talking about the second derivative here. All right, so for example, both of these functions are increasing, but they're increasing a little bit differently. This one has an increasing rate, and this one has it's increasing at a decreasing rate. So we're talking about the second derivative here. If we're going to draw the tangent lines, if you take a look, as we get closer and closer to this value, the slopes are getting steeper. All right, so this means that our function, this rate is increasing. The second derivative is going to be positive in this case. All right, and if we have these tangent lines on here, these tangent lines are decreasing. So we're going to talk about the second derivative being less than 0 or negative, because the slopes or the rates are increasing at a slower rate. All right, it'll make more sense once we look at a few examples. All right, oh, and also notice that here the tangent lines are below the graph. Okay, and on the other side the tangent lines lie above the graph. All right, if we look at the one when the tangent lines are below the curve, we're going to call this concave up. All right, concave up like a cup. Maybe that'll help you remember it. And similarly, this one's called concave down. All right, like a frown. And I'll get you some nice pictures along with that later. But this is the big idea of what we're talking about today. Concavity, how the rate is changing. All right, so in this graph, we just have to figure out where the graph is concave up, like a cup, all right, or concave down, like a frown. So concave up, all right, I'm just going to write this for the beginning, like a cup. When we draw the tangent lines, are they above the graph or below the graph? So maybe we should just draw a couple tangent lines, all right. Whoops. Where are they? And then these would be here. These will be here. So where are the tangent lines concave, if we're talking about concave up, like a cup, where are the tangent lines below the graph? So that would be on B to C. See, it's concave up like a cup. The tangent lines follow underneath. And also, we could say D to E, right here, and E to P, and that looks like it. So that means that on the other part, we're going to have concave down, all right, like a frown, on the other intervals from A to B. Okay, it's like a frowny face. Also C to D. And lastly, we have P to Q. And so we're talking about how it's changing. We're talking about how like the slope is changing, how the first derivative is changing. So that implies we're going to talk about the second derivative. All right, and so here's my little picture to go around. Maybe you'll remember it. If the second derivative is positive, then it is concave up, okay, like a cup. It looks like this. If the second derivative is negative, then it's concave down like a frown. There you go. Hopefully that will stick with you and you'll remember it forever. So let's look at an example here. Sketch a possible graph. So we get a lot of things going on that satisfies all of these conditions. All right, so let's break down what some of this means. Maybe we'll be able to piece it together. All right. When the first derivative is positive, that means that our function is increasing. So it's going to be increasing from -1 or negative infinity to 1. And then our function's going to be decreasing from 1 to infinity. All right, so we have a lot of different ways that this graph could look here. Here we have the second derivative is positive. So we're concave up, okay, like a cup, from negative infinity to negative 2, and also from 2 to infinity. And then we are concave down, that's this piece, in between those values from negative 2 to 2. Okay, concave down like a frown. And then the last part, this implies if we have a limit as x approaches negative infinity, as our graph comes over here, we're going to have a horizontal asymptote at y equals negative 2. All right, and then this one implies we're going to have a horizontal asymptote on that side at y equals 0. All right, so maybe on this side you kind of want to put those horizontal asymptotes in. You don't have to. And maybe, oh, that's negative 2, isn't it? All right, so I'm going to put them down here. So, and that just tells us the end behavior of our function. And now we're going to try to pull this together. So we want our function to be increasing. Put some values here. 1, 2, 3, 4. 1, 2, 3, 4. Good enough. All right, so we're going to be hugging this line, but we're going to be increasing all the way up until 1. And we're increasing concave up until negative 2. All right, so I could look something like this. All right, we're increasing, right, and concave up. And then we're still going to increase, but we're going to be concave down. We're going to increase all the way to 1. But we're going to be concave down. So maybe something like that, okay? And then we start decreasing from 1 to infinity. And then we're going to be concave down until 2. So something like this would be fine. And then what happens? Then we're concave up again and still decreasing. So we're going to be concave up. I'm going to have to change that graph a little bit because I forgot about this point. All right, wonderful. Let's see if I could pick this graph apart. All right, let's try that again. So I'm going to be decreasing and then decreasing. There we go. All right, so that is a possible graph of f. If we analyze some of these details, the information, when the graph changes from increasing to decreasing, we're going to have a relative maximum at x equals 1. So does it look like on our graph we have that almost? All right, maybe I should change it a little bit like that. There, that's a little bit better. So we have a relative maximum there. If we have this change in concavity at negative 1 and at 2. So we're going to introduce what that idea is. See how here it's concave down, concave up, concave up. We call that an inflection point. All right, an inflection point is where the graph changes from where the graph of f changes from concave up to concave down or vice versa. All right, so the sign of the derivative goes from positive to negative or from negative to positive. All right, concavity can change at a discontinuity, like a vertical asymptote, but that doesn't count as an inflection point. I'm going to write PIV for possible inflection values. All right, and then that's just like a critical value, but with the second derivative, where that's 0 or where it's undefined. Not every possible inflection value is an inflection value. That's why we put the possible on there. And we can look at some examples to help us determine when it is. All right, so 3a is pretty simple here. Determine the open intervals on which the graph is concave up or down. So we're looking at the second derivative. So the derivative of this would just be cosine of x. And then the second derivative is going to be negative sine of x. So this is defined for every value, so we're not going to have to worry about that. I'm going to try to save some room here. All right, but where is sine 0? Okay, and we know that that would be at 0, pi, and 2 pi. And we're looking on that specific interval. That's why I picked those values. All right, x, f, double prime. If we analyze what's happening, we have 0. Actually, I don't have to put that there. I could put that right on my end because that's the end point. So I don't need any more than that. So maybe I want to look at like 1/2 pi and 3/2 pi because they're easy values to determine. All right, so negative sine of x. If we plug in 1/2 pi there, sine of 1/2 pi is 1, so it's going to make it -1. All right, sine of 3/2 pi, that's -1 times negative, gives us a positive. All right, positive 1 value. So then our graph is concave up. Okay, remember, like a cup, we get our plus signs, concave up like a cup, on the interval from pi to 2 pi, and it's concave down, okay, like a frown, from 0 to pi. And then find any inflection points, so we could say f has, and remember, these were our possible inflection values, inflection point at x equals pi, since the second derivative changes from negative to positive at x equals pi. We could probably continue and do one more, but I'm going to give you some time. So I'd like you to try to do example B. So if you look on the next page too, we have a whole bunch more problems. We'll get to those tomorrow, but I want you to try this one and then let me know what you ended up with in class.